Good day, everyone. My name is Delu from Jiangsu Vocational Institute of Architectural Technology. I'm really honored to have this opportunity standing here to have my presentation for my paper, Harmonic Detection Method of Three-Phase Four-Wire APF based on PQR without voltage sensor. My paper consists of 5 parts. First of all, it is introduction. The three-phase four-wire active filter mainly has a four-leg or capacitive midpoint topology. The four-leg structure has a group of bridge arms more than the capacitive midpoint structure, which is designed to compensate for the midline current, and the compensation effect is better. The small number of switching devices used in the capacitor midpoint has attracted much attention in the small and medium capacitive system, and the medium line compensation and control strategy for the structure has been the focus of research. The IPIQ method, based on instantaneous reactive power theory, usually introduces a zero-axis decomposition current perpendicular to PQ planes, resulting in only active components in the zero-order component, which conflicts with the usual power understanding. The PQR method decomposes the voltage and current space vectors under the PQR space coordinate system, defines the active and reactive power of the zero-order components under the three-phase four-wire system, and the various power definitions coincide with the traditional power definitions, while the free power components are completely independent of each other and can be flexibly compensated without the need for energy storage components. The effect of midline compensation is improved, and the application of the midpoint structure of the capacitor is promoted. My paper consists of 5 parts. Now, let me show you the second part, detection principle of PQR. Under the condition of three-phase grid voltage asymmetry, the grid voltage under the ABC plane coordinate system is transformed to the three-phase orthogonal alphabet zero spatial coordinate system. Voltage synthesis vector ES is a special quantity whose projection on the alpha-beta plane is ESD, fixed to the zero axis in Figure 1a. To rotate the alpha-beta coordinate system counterclockwise angle theta, so that axis alpha coincides with ESD to obtain axis alpha SD. The axis alpha also rotates theta angle to get the q-axis, as shown in Fig 1b. Fixed the axis q, rotate the zero alpha SD coordinate system counterclockwise phi, so that the axis alpha SD coincides with the axis ES to get the axis P and the axis R, where the axis Q is perpendicular to the PQR plane, as shown in Figure 1c. My paper consists of 5 parts. Next, the 3-part harmonic detection without voltage sensor. In the case of system voltage distortion and imbalance, the PQR detection method discussed earlier is not able to accurately detect harmonic current. The following describes the improved PQR detection method without the need for voltage sensors and locking rings, which can detect each phase harmonic and midline current in the case of the grid is not ideal and achieve full compensation. When the voltage is distorted, the symmetrical three-phase grid voltage is like equation 7. The core of the PQR detection method is that EP in the transformation matrix should represent the positive sequence component of the grid voltage when the vector coordinate transformation is performed. Consider that the point can replace the actual result of the power grid voltage detection with a three-phase frequency sign unit vector under the environment of grid voltage distortion. The distortion asymmetric current expression is equation 9, and the improved transform can be obtained like equation 10. So Figure 2 shows the improved PQR method of detection. My paper consists of 5 parts. Now let me show you simulation analysis. The simulation model is established by MATLAB. Figure 3 shows RPIQ I0 method, and the simulation model of PQR method is shown in Figure 4. The non-linear load in the simulation is a three-phase non-controlled rectifier bridge. The DC side is connected with two 4-ohm resistors. The midline is drawn from the midpoint of the DC side, and the inductance of the AC side of the DC bridge is connected by 0.2 milliohm. When the grid voltage is free of distortion, the voltage and the current of the load are shown in Fig 5, which shows that the load current is severely distorted and unbalanced, containing a large number of 6K plus or minus 1 harmonic. The positive sequence current of the load fundamental detected by RPIQ I0 method and the harmonic current to be compensated are shown in Fig 6. The positive sequence current of the load fundamental detected by PQR and the harmonic current to be compensated are shown in Fig 7. The positive current of the load base wave detected by the RPIQ I0 method and the harmonic current to be compensated are shown in Fig 6. The input AC voltage fundamental wave effective value EA1 is 220 volt. Fig 8 shows the grid voltage and load current waveforms. When the voltage of the grid is unbalanced. In the case of grid voltage imbalance, the improved PQR method uses unit sign signal instead of the real-time grid voltage detected by the voltage sensor, and the resulting A phase and B phase best wave spectrum is shown Figure 9b and c, which can detect harmonic currents in real time. Fig 10 shows the midline current compensates for the front and the rear waveforms. My paper consists of 5 parts. Above all, we can get to the conclusion. This paper mainly introduces the basic principle of PQR harmonic detection method under the three-phase four-wire system and puts forward the PQR harmonic detection method of voltage-free sensor. Simulation proves that the improved PQR detection method does not require a voltage sensor, and the positive sequence components and harmonic components of the current-based wave of the grid can still be correctly detected in the case of uneven grid voltage. The capacitor midpoint active power filter uses the harmonic detection method to compensate the midline current well, which greatly simplifies the engineering difficulty and cost, and promotes the popularization and application of capacitive structure active power filter. Thank you very much for watching my presentation, and never be hesitate to contact with me by email. Thanks again. My paper consists of 5 parts.